What's up game developers, CouchFerret here, and today we'll make a new player controller from scratch. We'll start by processing the raw inputs to create movement direction and movement speed variables from them. Later, we'll use these variables to implement our archer's movement and to animate him with blend trees. We'll also cover topics like sorting order, inspector windows headers, and colliders. If it sounds fun, then stay with me and consider subscribing with the bell icon so you won't miss any future videos of this game. Cool, let's begin! Before we get started, I wanted to let you know that I've created a Twitter account where I'm posting teasers and behind the scenes stuff about my videos and my game. I'm also hoping to hear about your game and the progress you're making, so feel free to tweet me screenshots, GIFs and videos, whether you are looking for feedback, help or just want to share. So come follow me at CouchFerret on Twitter and say hello. Okay, let's start by boldly removing the old Archer game object and its sync and player controller scripts. And also delete the existing animations and sprites that are related to the Archer. Now we have to create a game object for our new Archer. Let's hit right-click in the hierarchy window and select Create Empty. Let's name it Archer and we can zero out its position by clicking the gear icon at the top right corner and selecting Reset. Under the Archer game object, let's have a new empty game object called Sprites. We'll put all the sprites under this game object so we can handle their sorting order together. But I'll get to that. First, we need to import the new sprite sheet we made in the last two episodes. Check those videos out if you haven't watched them yet. This is the Archer's sprite sheet and we have a lot of frames. To import it, we need to drag and drop it from the file browser into Unity. Let's drag it under Graphics, Archer and rename it to Character. Now we need to change the import settings to make it suitable for pixel art. Let's change the sprite mode to Multiple, filter mode to Point No Filter and compression to None. Hit apply and let's open up the sprite editor. Let's now slice this sprite sheet by grid by cell size with 30 by 30 pixel size. If we hit the RGB icon, we can change it to alpha only mode where we can see clearly the grid we've just created. Let's hit apply and close the sprite editor. Now we can see all the individual frames under the character sprite sheet. Let's select the first one and drag and drop it on the sprite's game object. A new game object appears with the sprite renderer on it. Let's remove the suffix from the name and move on to the player controller script. To create a new player controller script for the Archer, we can just select the Archer and hit Add Component. Scroll down and select New Script and name it Player Controller or whatever you like. Let's drag the script in the asset directory into the scripts directory. After a double click, we can start implementing the character's movement. The first thing I'm going to do is declare two variables for the rewired input system asset that I use for this project. Don't worry, you don't need to buy it. I'll be pointing out the differences so you can use the built-in input system instead. For rewired, I have to declare a player ID so I can tell rewired which player it is. Let's have this one be public so I can set it in the inspector window later. And I need to declare a rewired player variable, which is the variable that I can access the inputs through. But this doesn't have to be public because we don't need it in the inspector window. And I have to import rewired itself with a using rewired statement. Finally, I'm initializing rewired in the awake function. So if you aren't using rewired, you don't have to do any of this. Let's move on now to processing the inputs. Let's create a process inputs function for handling the inputs. The first thing we need is a movement direction vector. Let's declare it globally so we can access it later from other functions too, and also as public to see it in the inspector to make sure it works properly. Because the game is 2D and we don't need the z-axis, we can declare it as vector too. Now we have to assign a value to it based on the player's inputs. Let's assign to it a new vector too with player.getAxis horizontal and player.getAxis vertical as its x and y coordinates. If you are using Unity's built-in input system, then yours should be input.getAxis horizontal and input.getAxis vertical. From now on, every time I access the inputs through the player variable, you should access them through the input class instead. This is the only difference you will have in the scripts, and of course the few lines we did earlier to initialize rewired. Cool, we have the direction. Now we need the movement speed and we'll have everything to move our archer. This movement speed variable will represent how far the player has pushed the analog stick from the center. The further it's pushed, the faster the archer runs. Let's declare this variable also as global, public, and have it as a float. Let's have its value set to movement direction.magnitude, which is the movement direction vector's length. Because not all controllers are equal, we need to clamp this value to prevent it from going beyond 1, which could allow players with tricky controllers to move faster. We can easily do this by wrapping the value in the mathf.clamp function. Its first parameter is the value we want to clamp, the second and the third are the minimum and maximum values it can take. Lastly, it's also wise to normalize the movement direction vector, so it won't change the speed of the archer's movement when we use it. A normalized vector's length or magnitude is always 1, except when the vector is a 0 vector with all of its coordinates as zeros, then its length is 0. Okay, before we can try it out, we need to call the processInputs function in the update function, so the inputs are processed in every frame. Let's jump back into Unity. Now I'm quickly redefining the rewired inputs for horizontal and vertical and assigning them to the left stick's X and Y axis. For the built-in input system, Unity defines these by default. Let's try it out. By moving the stick, we can see in the inspector window that the movement direction and movement speed variables change. Now it's time to move our archer. We move him with Unity's physics engine, so later when we handle collisions, it will work fine. First, we need to give the archer a rigid body 2D component to make him participate in the physics simulation. Let's select him and in the inspector window, hit Add Component and search for rigid body 2D and add it to him. Zero out the gravity scale and freeze its rotation on the Z-axis, so he won't spin around in the future. Let's jump back into the code editor and declare a variable for the rigid body 2D component so we can access it. Name it RB and save the script. Now we have to fill this variable in the inspector window by dragging and dropping the rigid body 2D component into the variables field. To move the archer, we need to change his velocity based on the player's inputs. Let's create a new function called move and call it in the update function as well. Let's change the rigid body 2D component's velocity variable to movement direction multiplied by movement speed. In this multiplication, the left side is a one length long unit vector and the right side is a simple float with values between 0 and 1. The movement direction gives only the direction of the movement because its length is 1 and multiplying the speed with 1 doesn't change it. And because the movement speed is just a float number, it can change the direction of the movement. There are few exceptions when they are zeros, then the archer doesn't move anyway. Let's try it out. It works. If we want to change the archer's overall speed, we can just multiply the expression with a float of our choice. You know what? Let's create a speed setting for the inspector window. We need to declare a new public float variable called movement_base_speed. I choose this capitalized and underscored style for this variable to imply that this variable doesn't change very often and defines the base characteristic of the archer. Let's have a default value of 1, so if we forget to set it, it won't break our game. Instead, it won't have any effect. Now we only need to multiply the expression that defines the movement. Let's hit play and try it out. Now his speed is normal because the default value is 1, but let's change it to 3. Now he's hyper fast. If we change it to 0.3 instead, then he becomes sluggish. Cool! With this setting, we can create characters with different speed without modifying the code. Our player controller component starts to have a lot of variables visible in the inspector window, which makes it a bit confusing. We can make it more organized with headers and extra spaces between variables. Let's jump back into the code and figure out how can we categorize our variables. The first group of variables is related to the input handling, so let's have a header for them with the title Input Settings. The second group is more about the archer itself, so a character attribute's title would be good. And I'm also putting space between these two groups with space. The third group is also about the archer, but only for telling us information about him. So let's call it character statistics. And the last one will contain references to components, game objects or prefabs. So let's have a header with references in it. Now save the script and let's see how it looks in the inspector window. This is much better. Okay, let's hit play and see where we are. We can move, but there's no animation and there's an issue with the sorting order of the sprite. The walls, grasses and flowers are weirdly rendered in front of the archer when they are behind him. We can fix this with a sorting group component. We need to select the archer game object's sprites child object and add a sorting group component to it. This ensures that all sprite renderers within the sprite's object's descendants will be sorted together and is based on the sprite's object's position as pivot. We also need to move the character child object up a bit because the sprite's game object's pivot is at the archer's face and we want that around his legs. Now Unity compares that pivot point to other objects' pivot point, and whichever is farther down will be rendered in front. Make sure that in the project settings, graphics, you've set the transparency sort mode to custom axis and the axis to the 0, 1, 0 up direction. If we test it now, then the sorting order between the archer and the grass flips just in time. Cool! Now it's time to do the animations. We'll do most of them with nested blend trees, a forest of them. But first we have to create an animator controller, so let's create one under the animations archer directory. Let's name it character. Now we need to select the archer game object's character child object and we need to add an animator component to it. This component has a controller variable. If we drag and drop the animator controller asset, Unity creates a reference for the component to the controller asset. Let's open up the animator and animation windows and make sure to have the character game object selected. Now we can start creating the animations by hitting the create button in the animation window. Let's create one with the name idle down and save it next to the animator controller. Change the sample rate to 12. Now we have to find the right frame in the sprite sheet and drag and drop it into the timeline. With that done, let's now create the rest of the 7 directions. Done. Let's remove them as simple states from the animator and create a new blend tree state. Let's rename it to movement and double-click it to go deeper into the blend tree. Now we have to select the blend tree node so we can change its settings. We use this blend tree to handle the different directions and transition between them based on the movement direction vector. So let's change its blend type to 2D simple directional. By default, Unity created this blend animation parameter, but we need a horizontal and a vertical instead. Let's rename the blend parameter to horizontal, create a new float animation parameter and name it vertical. Now we have to change the blend tree's parameters to horizontal and vertical so it uses the right values to blend. We can add the idle animations as motion fields one by one with the plus icon. Let's add 8 new motion fields and select the animations from idle down in counterclockwise order. While we added the animations, a diagram showed up with blue and red points in it. The blue points represent the animation's direction. So let's fix them by changing the X and Y positions of the motion fields. Idle down should be 0, -1, because that's the down direction's vector, and similarly to this, idle right down should be 1, -1. Fixing the rest of the directions as well, we get a rectangular shape. Let's go back to the base layer and make sure that this blend tree state is the layer default. Okay, the animator controller is done for now, but before we can try it out, we have to set the animation parameters value in the code. So let's jump back into the code. Let's create a separate function for the animation and call it animate. We'll set the animation parameters value in this function based on the movement direction vector. But before we can access the parameters, we need to create a public variable for the character's animator to have the reference to the component. So let's scroll up and declare the variable. It goes into the references group. We need to save it and set the variable's value in the inspector window. Let's click the small circle next to the field and select the character game object, because that's the one that has our animator component. Now we can jump back into the code and access the animator. Let's set the horizontal animation parameters value to the movement direction.x and the vertical to the y. Finally, we need to call this function in the update function, so it's being called in every frame. Let's test it out. Although he's sliding around the map, the animation is working. He's facing the direction where he's moving. Now we only need to handle the speed as well and change the idle animation either to the walking or the running ones. Let's do that. First, let's go to the animation and animator windows and select the character game object so we can create the walking and running animations. Similarly to the idle animations, we can create them by hitting Create New Clip, naming them, setting the sample rate to 12, and dragging and dropping the frames into the timeline. Let's repeat this process for all the walking and running animations. Okay, let's change the blend tree to handle walking and running animations as well. First, we need to create a new animation parameter for the movement speed variable. Let's call it speed. I'm also deleting the simple states, we don't need these. Our current blend tree handles the directions. We could change its type to 2D freeform directional, which handles multiple motion fields in the same direction, but I prefer creating blend trees inside this blend tree. Unity allows us to nest blend trees, so if we create blend trees instead of the idle animations we have in our blend tree, then we can use these nested blend trees to blend between the idle, walking and running animations based on the speed animation parameter. Let's hit the plus icon in the inspector window, but this time instead of hitting Add Motion Field, let's hit New Blend Tree. Move this new blend tree up and copy the X and Y values from the idle down motion field. Let's select it and rename it to down. In this case, we only need a 1D blend tree, because we'll blend between the 3 down animations based on the speed parameter. So we need to change the parameter to the speed parameter. And also let's add those animations as motion fields. We need to uncheck the Automate Thresholds checkbox so we can set the thresholds ourselves. These thresholds determine when the blend tree changes animations. The idle motion field is good at 0, but let's move the walk motion field really close to the idle, so the blend tree almost instantly switches to the walking animation when the speed parameter increases. The threshold at 0.0001 should be close enough to make the transition happen immediately. The running animation at 1 is perfect. Let's select the character game object and then the blend tree again to make the preview window work in the inspector. Now we can hit the play button and preview the transitions. Moving the red slider in the diagram, we can change the speed and see the blended animation. If I increase the speed from 0, then the archer starts walking immediately. Now we only need to remove the idle down motion field in the previous blend tree, and our animation will have these transitions in the down direction. Let's try it out before we do the rest of the directions. Oh, okay, I haven't set the speed animation parameters value in the script. Let's fix that quickly. Now it's perfect, we only need the rest of the directions. Let's do the same steps with the other directions, like creating the 1D blend tree, setting the motion fields in it, and replacing the original motion field with the new blend tree. And also don't forget to set the blend tree's X and Y positions while deleting the simple animations from the blend tree. Our blend tree is growing bigger and bigger, but imagine the number of simple animation transitions we would have to do if we weren't using blend trees. If we hit play, we can see our animation working like a charm. One thing a lot of you guys pointed out is that when the archer stops moving, then he turns back to the down direction instead of facing the last direction he moved in. I'll show you a quick fix to solve this easily. If we take a closer look at the character statistics in the inspector window while we are moving with the archer, we can clearly see that when we stop, the movement direction variable jumps back to the 00 vector. In the code, we use this vector to set the horizontal and vertical animation parameters. It turns out that when the blend tree gets a 0 vector, which represents no direction at all, it defaults to the downward direction. Let's jump back into the code and modify the animate function a bit, so we won't set 0 vectors for our blend tree. I use an if statement with a condition that checks if the movement direction equals to the 0 vector or not, then put these two lines into the if statement's block. With this, we only set the animation parameters when the movement direction isn't a 0 vector, so there won't be cases where the blend tree gets an ambiguous direction. Let's try it out. When I stop pulling the stick, the archer stays facing the same direction. Awesome! Let's finish up this episode by adding a Circle Collider 2D to our archer so he won't be running through walls. We made this wall stuff in a previous episode on colliders. Check that episode out if you haven't watched it. Let's select the archer game object and add the Circle Collider 2D to it. We only need to adjust the radius to maybe a 0.03 and we are done. Now he can go through walls. Today we created a player controller from scratch with movement and animation. How cool is that? That's it for today, folks. Next time we'll continue to work on the player controller by adding aiming animations and the arrow shooting mechanism. So be sure to subscribe and leave a thumbs up. If you have any questions about what you have just seen, feel free to ask and I try to answer all of them. See you next time!